Hey guys, Sebastian from Madrigal here. What you're looking at is Project Slide. It's a game that I'm working on using my own game engine called Basis. Today we're going to start looking at porting Basis over to the Vulkan API. So Vulkan is a reasonably new so-called modern API in that it puts a lot of emphasis on the actual game or app programmer. It takes responsibility away from the graphics driver. And so the big idea is that when used correctly, you can get a lot of performance out of the Vulkan API. Or another so-called modern API such as Metal or Direct3D 12. Now Basis currently works on Direct3D 11 on Windows, which you can see here up in the corner. It says D3D 11. And it also works on the Metal API, which is also considered to be a modern API, same as Vulkan. But it's probably the most easy to use modern API. And Metal obviously only works on Apple platforms, so in my case the Mac. So why am I looking into Vulkan? Well, the main reason is compatibility with new operating systems. So in my case, in particular Linux, I would like to actually port Project Slide to the Steam Deck. It would be pretty cool to have it running natively on Vulkan. And obviously Vulkan also runs very nicely on Windows and even to some extent on Mac. Although since I have the Metal backend already working quite nicely, I doubt that I'll actually use it on Apple platforms, but it's a possibility. And the reason why I'm doing it right now is that I've actually looked at Vulkan previously, and I had a backend working for the Basis engine, sort of. But it was at the time when I had just started looking into the new modern APIs. I didn't really know what I was doing, not that I'm that much more knowledgeable now, but still. It ended up being sort of a mess, and I had to complicate my graphics engine quite a bit to make it work. And at the time I started thinking that while the Vulkan API is pretty cool, it would be nice if someone made like an abstraction library to bring it a little closer to the classical APIs. Something along the lines of the complexity that Metal gives you. Something that you could use to sort of ease the transition a little bit. And then when you feel more comfortable, you can start removing that abstraction if you want to and sort of reap the benefits of Vulkan completely. And it turned out that there actually exists such a library. There might be actually several, but the one that I found, which I like the look of quite a lot, is called VEZ. So here you can see the GitHub repository. And VEZ is actually made by some people who apparently work at AMD, so they should sort of know what they're doing. So what is VEZ? Well, you can see from this image here, you have the official Vulkan API and all of its components. All of these boxes represent something that you as the game or app programmer have to manage and set up correctly and use correctly. And then you have the VEZ model here on the bottom, and you can see a lot of these boxes are grayed out. So VEZ tries to manage about 50% of the whole thing for you and make the rest a little easier and a little closer to something like OpenGL. And what I like about VEZ is that the code actually looks quite nice. As you can see here, it's very well commented. and quite sort of clean, which means that if it does something perhaps not as efficiently as you would like, there's a pretty high probability that you can actually just modify the code yourself and go directly to the Vulkan level and work directly with Vulkan. But especially for someone like me who is not super experienced as a graphics programmer, it's quite nice to have something like this where you can start at sort of like a slightly easier level and work yourself up from there. So that's what I was thinking we would do in this video series. It will probably be more than one part because Vulkan is still Vulkan and graphics APIs in general are very complicated. So we'll see how it turns out. Now Vulkan is actually what you might consider abandoned at this point. The last update is from 2018, so about 5 years at the time of writing. But there seems to be something of a small community actually forming around this thing. You have 12 pull requests here, some of them fairly recent. And some of these are actually really good and valid fixes. In addition to that, there is a fork up on GitLab, not GitHub, but GitLab, which is fairly recent as well. And what I've done is that I've taken this branch and I've integrated some of these fixes from the official list of pull requests, or shall we say pull requests to the original repository. And I've created my own branch of VEC. And I'll put the link to both the original one and my own fork in the description below if you're interested. However, be aware that I'm not super experienced with Vulkan, and some of these fixes that I've put into my own branch might be of questionable quality, shall we say. But they have given me pretty good results. So, what are we going to actually do in this video series? Well, first of all, I seem to have multiple instances of the game running here, so that's not good. Okay, so we don't want to go super crazy and even imagine us creating like a very efficient Vulkan renderer. That would take months, if not years, for someone like me to actually do. So what we're trying to do here is get our trusty demo level and this small intro sequence here rendering. Well, we'll actually try to get it rendering completely correctly. So I think we have a lot of really interesting things to tackle here. While the renderer is pretty simplistic, we actually have a lot of fairly complicated effects going on here in this scene. So we can toggle some of them on and off. Like we have shadows, we have real-time shadows, we have screen space, ambient occlusion. We actually have HBAO+, which we probably won't have with the Vulkan one, because that involves some third-party code that I need to look at. But if we don't have that, then we can have the basis engine's built-in SSAO working, and that should be fun. We have SMAA or FXAA, which is an anti-aliasing solution. We have, if we actually drive around a little bit, well, we have particle systems, not very good ones, but still. We have bloom from the headlights. We have water here with real-time reflections. If we move the camera away, we can see that it reflects the car and everything. What else? What else? Well, we have sky and we have really distant object rendering. We have light maps, which of course they're sort of baked, so they're not super interesting from like a real-time perspective per se. But yeah, we also have some like volumetric lights and things like this, but they're actually not used in this scene currently, so they don't really apply. As you can see, this scene doesn't actually run even that well on D3D11 currently. This machine is not my best one or my main one, but it's the one that I use for recording these videos, and I think this would actually be a pretty nice machine to work on rendering things, especially because it doesn't have the best GPU. Right, so in a nutshell, we'll try to get this scene looking correct with some small disclaimers like the HBAO stuff. And it will probably not run as well as the D3D11 one. Performance comes later, and it won't be a part of this video series. Well, let's try to just make it run. And there's enough of a challenge in that. Right, so how is this thing actually gonna work? How are we gonna do this? Let's shut the game off and have a look at basis. So how we actually select our rendering backend comes down to loading a plugin. So here we actually just hard-codedly select D3D11 if we are on Windows, and if we are not on Windows, we select Metal. And we say here that we assume macOS. And these are loaded as plugins. You can see that we also always load the PhysX plugin. So what's a plugin? Well, it's essentially a DLL file. We go to File Explorer, and we can see the slide exe is here, and we have our basis GFX API D3D11 DLL. It's a very small DLL. It contains almost no logic at all. one could argue, and you have some other plugins as well here. Like here's the PhysX one, which we load here. The Metal one doesn't show up here on Windows, obviously, because there's no point in actually trying to build that on Windows. It won't build. It's a Mac only thing. And the idea here is that the core API, the core engine, which is this DLL here, it has no idea what graphics API we're using. Instead, it uses something called GFX API, which you can see here in the name, GFX API D3D11. So this backend plugin here is essentially a bridge between GFX API and D3D11, and we're going to create a new plugin from GFX API to Vulkan. And so what's GFX API? Well, it is essentially Basis Engine's own graphics API, if you will, which you can see here on the left. And this contains classes, types you might typically find in a graphics API. So we have a buffer, for example. You can map the buffer and you can unmap it. You have a texture. You can write data to the texture. You can read data from the texture and get some other information from it. What else? You have a render target, like this. Some setup structs there. And then perhaps the most interesting thing here is the render context, which is essentially like where the actual logic of doing something happens. So you have begin frame, end frame, you present to the swap chain, begin render pass, you bind things, vertex buffers, index buffers, you can bind structured buffers, textures, texture samplers, and you can draw. And both the game itself and the core engine, they only use this GFX API. You can see all of these are virtual. So we're actually going to implement the classes for the Vulkan API. So that narrows it down quite a bit to what we actually have to do and in which places we actually have to add things. So if we go to bases, we can see here we have D3D11 and we have metal. So what I'm actually going to do here in this first part is that I'm going to copy this metal one, and we'll add a new one called Basis GFX API VK. And so VK is typically how you actually shorten Vulkan. And the Vulkan API functions always start with VK. So here we have all of the metal classes. We can actually open this up now in something like Sublime. Let's open it up. Let's open it up. Let's see what do we have. Actually, let's not do that. Let's go open folder. Put our folder here. Right. So here we have the metal ones, and I'm going with the metal one because it's in some ways it's the one that more closely resembles the Vulkan one compared to the D3D11 one, for example. Okay, so here you have, for example, the buffer implementation for the metal backend, and we're going to take this and make it work with Vulkan. Okay, so how do we do this? Well, first of all, we'd like to rename all these files to basis buffer VK, basis GFX backend VK, etc. And these MM files are essentially Objective C++ files. So if you don't know what Objective-C is, then lucky you, I should say. I don't particularly like Objective-C, but it's the way that you use metal from C++. It's the easiest way, at least. You can also use it from Swift, obviously, which is what Apple would like everyone to do. But if you're interoperating with C++, then Objective-C++ is easier. And it's these lines that you see that are sort of enclosed in these square brackets, and these are our Objective-C calls. So we'll want to rename these to CPP because we're working with just straight C and C++ with the Vulkan backend. So let's just get to work, shall we? Well, I don't know if there is a very good way to actually automate this, but we're not going to do that now. All right, so there we have our files renamed. Incidentally, if you know of a good way to do this kind of intelligent renaming, then by all means let me know. Right, so I mentioned briefly that I used to actually have a Vulkan backend previously, and I'm going to use a couple of files from that incarnation of this plugin. Things that I did back then that were pretty good. Oh, actually, I don't want to put those there. I'll show you what they are. So first of all, we have this texture loader, DDS texture loader. So wait a minute. Does this thing go there? It might go. we'll see. I'm just going to delete this mm file here. So what's this DDS texture loader? Well, it's essentially a Microsoft DDS texture loader for D3D11 and 12, and I've added my own version. So here we have a Vulkan version, which is like behind the define like this. We have the D3D11 version behind the D3D11 define, and I might actually have the wrong version here of this thing. I think I have the wrong version here. Let's see, what do we have here? Yeah, that looks correct, but I think this DDS texture loader is the wrong version. Nevertheless, I'll figure it out and use the right version. But for this DDS texture loader, I added a version of this which works with the VEZ library and tested it out with the VEZ samples, so that rather than just loading straight from like a PNG or a JPEG file, I can load textures directly from DDS files. So let's use that. Let's not rewrite that. That would be silly. And then the other thing that we're going to use, which I actually wrote myself last time, is this type conversion .vk or v type conversion. It's actually called Vulcan because that's what I called it back then. Let's call it VK. And this is just switch cases, switch case after switch case. And what this does is it takes a graphics API blend operation and turns it into a VK blend operation, or a texture filter and turns it into a VK filter. So this is sort of how we can convert data types from the GFX API, so the basis native ones, into the Vulkan native ones. And obviously just recreating these for this video series would be kind of silly, because these formats haven't changed that much since last time I did this, and this just works really well. So let's use this. Let's use this stuff. All right. So I'm just going to make sure that I have the correct version of this DDS texture loader. But other than that, we have essentially our files here. The next thing we need to do is get the CMake list working. So I use CMake for basis and for slide. And essentially what we want to do here is just go through and rename these to their correct versions. So like that, and then medal.h would be vk.h. Like this. We still have some metal things here, so let's rename those. Do CPP. And that would be CPP as well. All right. And here we can add the library, so let's call this basis GFX API VK. And we're going to use GLFW, which is a very nice library. We actually already use it for the metal one to create the window and things like that. But we're going to use it for the Vulkan one too. And these we don't need. Those are Apple libraries. Let's get rid of that. This should probably be called VK as well. And we need to rename all of these to VK. that can be called vk_d in debug mode. Right, I think I still need to I need to go into CMake modules and get the targets here. I've already added VEZ as a library, and we will obviously need to link to VEZ, and we also need these spur-v cross libraries that VEZ itself needs, so we'll add those as well. Right, that looks good, and that should be called basis VK, right? So now we can search, do we have any metal left? No metal here in this one. Good. And I think if we go back to CMake and we try to configure... Oh, actually, we need to do one more thing. Actually, a few more things, right? A few more things. First of all, let's add the project here. So let's add it just for Win32 currently. So here we add the D3D11 one. We'll also add the VK one. Let's not add it for Apple because I don't think we'll actually use it there. That's one thing. We had the middleware stuff here. I think I actually added Vulkan as one as well. Yes. So Vulkan comes with comes in the form of a Vulkan SDK, which you can download from the LunarG website. So we just need to have the Vulkan SDK include, and it actually adds this Vulkan SDK environment variable for you. So this is all you need to do. You need to link to the Vulkan 1 library and include the Vulkan include folder, and we should be good to go. Like so. And then the last thing we'll probably want to do still is in Slide, the Slide game project. Open up here. We have the dependencies here, and this just means that currently we are depending on D3D11 and PhysX, which means that Visual Studio will build those when you build Slide. So let's just add VK there as well. It can build both of them, and then we can perhaps have some kind of selection, like do you want to run it in Vulkan or D3D11? And I think that should be it. Let's try to configure, generate, and we should just be able to reload this thing. So let's see what we have. And here we have our new Vulkan library. Now this is obviously not gonna build because we're still talking about metal here in the actual code. So what I will actually do now is I will end this part, and I will off camera just clean out all of this metal code that I think we don't want here. And in the next part we'll start to actually write our Vulkan code. So I hope you enjoyed this. I hope you're with me on this crazy journey of getting a quick and dirty Vulkan renderer up and running in an actual game project. Click and bash and like and smash all the buttons. You know what to do, and I'll see you in the next one. Bye.